What is happening to the largest ice shelf in Antarctica? Is it moving? And if so, how much? Welcome, friends. Jim here. Largest ice shelf in Antarctica. Lurches forward once or twice each day. So this appeared in phys.org. And we're talking about the Ross Ice Shelf region. And it shows the location of various seismic stations. These are the blue circles. And what is happening? You can see you've got the Transantarctic Mountains. Let's see if I can enlarge this a little bit. There we go. Okay. So seismic stations used in the study are labeled. That's these blue dots here. Also equipped with a global navigation satellite system, denoted by the asterisks. Those are other stations. The grounding line, that's right here, this red line. Okay. The grounding line. And they also indicate the Whillans ice stream slip asperities, which is up here. So here we have the Ross Sea. Here's the Transantarctic Mountains. Here's the ice shelf. This is the grounding line. All this is over the ocean. In Antarctica, heavy glaciers are always on the move. Conveyor belts of ice, known as ice streams, are the corridors of faster flow that carry most of the vast glacier's ice and sediment debris out toward the ocean. One such ice stream jostles the entire Ross ice shelf out of place at least once daily, according to new research from Washington University in St. Louis. This finding is significant because of the scale of the Ross ice shelf. It is the largest ice shelf in Antarctica, about the same size as the country of France. We found that the whole shelf suddenly moves about 6 to 8 centimeters, 3 inches or so, once or twice a day. Now you're going to say, 6 to 8 centimeters, that ain't much. Think of the mass. Think of the size. Usually it's triggered by a slip on an ice stream that flows into the ice shelf, said Doug Weens, the Robert S. Brookings Distinguished Professor of Earth, Environmental, Planetary Sciences, and Arts and Sciences. These sudden movements could potentially play a role in triggering ice quakes. Ice quakes, I like that word. And fractures in the ice shelf. The Ross Ice Shelf is a floating lip of ice that extends out over the ocean from inland glaciers. Scientists are interested in the interaction between ice shelves and ice streams, in part because they're concerned about the stability of Antarctic ice shelves in a warming world. Ice shelves act as brakes for glaciers and ice streams, slowing their journey to the sea where they melt, thus allowing more ice to accumulate on the continent. If an ice shelf collapses, this support disappears and the glaciers are free to flow faster. Once they flow into the ocean, they contribute to sea level rise. And let's point out that in addition to such ice shelves, sea ice also acts as a brake, a buffer, to slow the movement of land ice into the oceans. New study in Geophysical Research Letters focuses on movement triggered by the Whillans ice stream, one of about half dozen of the large, fast-moving rivers of ice pouring into the Ross ice shelf. Okay, one does not usually detect this movement just by feeling it. The movement occurs over a time period of several minutes, so it's not perceptible without instrumentation. That's why the movement has not been detected until now, even though people have been walking and camping on the Ross Ice Shelf for, well, a while. The movement of the Ross Ice Shelf is triggered by a relatively sudden, in glacial terms, movement of the ice stream called a slip event, sort of like a strike slip fault for earthquakes. It is somewhat similar to the stick slip that occurs along a fault before and during an earthquake. Yeah, I guess strike slip is the more vertical movement, if I recall correctly, and stick slip is probably more horizontal. But it's the same kind of notion. Two moving sections, kind of due to friction, kind of get ground into each other, and then due to continual movement, the pressure builds until something gives, and then it moves. Under the scenario that Wiens and his team observed, a large section of the Willem's ice stream measuring more than 100 kilometers by 100 kilometers, that's 10 to the 4 square kilometers, that's a wee bit big, remains stationary while the rest of the ice stream creeps forward. Then once or twice a day, the large section lurches forward against the Ross Ice Shelf. So presumably if you just have parts that are remaining stationary and other parts that are moving, you are going to create pressure, and the pressure needs to be released. It can move as much as 40 centimeters in a few minutes. Studies of ice streams over the past 50 years show some speeding up, others slowing down. Scientists can use seismographs to detect the sudden motion of the ice streams in an effort to understand what controls the motion. Researchers do not think that these slip events are directly related to human-caused global warming. One, I would say, hypothesis is that they are caused by the loss of water in the bed of the Willem's ice stream, making it more sticky. The stress and strains associated with slip events are similar to the stress and strain observed to trigger ice quakes under different conditions. Now, what is not mentioned here, not discussed, is what's the role of the ocean underneath, right? If this is the grounding line, this is on the ocean, right? It's all cantilevered over. So what is the role of the ocean? Especially that the oceans are warming. What's that doing to the ice shelf? That is most likely, from what they're implying here, that's most likely a different mechanism than what has been described here. But I still find this interesting, and I don't have data to address this, but I'm going to toss this out there. Does a warming atmosphere lead to an increase in the amount of slipping and lurching that goes on? Does the warming atmosphere along with the warming ocean help, say, lubricate some of the ice? I'm just putting that out there. So I thought this was interesting, and I thought I'd share it with you. Thank you for your time. Talk soon.